Good day, students. I'm going to do this section in several parts just so the videos are a little bit shorter and you can kind of do them as you want to. The first part, we're going to do just kind of a quick unit circle review. And we already kind of went through the unit circle. I'm just going to run through this one more time. This section, you're going to do a lot with the unit circle. A lot of problems where you're just doing all 6 trig functions in a unit circle. So I want to go over that. You want to make sure that you know all of your definitions. Again, just to review, the sine is the y value. So if I wanted the sine of pi over 6, that would be 1/2. The cosine is the x value. That's a typo right there too, so I need to get that fixed. That's the x value. I have it right there. So the cosine of 30 would be square root of 3 over 2. All right. And then just remember the sine and cosecant are reciprocals. The cosine and secant are also reciprocals. And then the tangent's y over x. That would just be the y value over the x value. And then the cotangent's the reciprocal of the tangent. Okay, so you want to know those definitions. So what I'm going to do on this, just kind of refer to the unit circle to do these problems. And this is just kind of a quick review before we go on to some new topics. So if you were doing the sine of 7 pi over 6, on your unit circle, you would locate 7 pi over 6, and you would find the y value. So the answer to that problem is -1/2. Doing a sine and cosine is very quick on this, okay? We want to do the sine of 60, locate 60. Again, find the y value. So that would be the square root of 3 over 2. Okay, now we want to move to the cosine. So the cosine of 2 pi. 2 pi is 1 lap around the circle. All right, the cosine is the x value. Therefore, the cosine of 2 pi would be 1. Okay, like that. Now, what I want to do here is pause this video a little bit and let you try to do the next ones and see if you get those okay, and then we'll kind of move on because I don't want to spend a lot of time on this since we did this a lot in the last section. So go ahead and pause, give yourself a chance to see if you can get these worked out. Then when you're ready, just resume and we'll check your answer. Okay, so go ahead and check and see if you got the right answers on these. If you did, if you got the right answer and you understand, you can just move on. I am going to go ahead and just run through these and make sure that we're on the right track here. So it's a little bit easier if I do these over here so I can take up a little bit more room. So number 4, you have the cosine of -390. Okay, just, tuck that out. You're going clockwise 360 plus 30 more. So you actually are here at 330 degrees. Okay, the cosine's the x value. Therefore, that's square root of 3 over 2. All right. Find the coterminal angle is what you want to do. Next one was secant of pi over 6. Okay, remember that's really 1 over x. So you can find the x value and do the reciprocal. So pi over 6 is right here. The x value is that. So when you do that, you're going to get this. You take the reciprocal of that x value. So you get 2 over root 3. Then you want to rationalize the denominator, like we've been doing, okay, and multiply by that, and then you'll have the answer 2 root 3 over 3, okay. Review the rationalizing denominators if you need to in previous videos. Okay, number 6, we have the secant of 2 pi. Okay, again, it's 1 over x in the unit circle. That's what the definition of the secant is. So 2 pi is 1 lap around the circle. The x value is 1. So you're just doing the reciprocal of 1, which of course is 1. So one thing, notice on this, 3 and 6 have the same answer because the secant's the reciprocal of the cosine. All right. Okay, number 7, we have the cosecant of 240 degrees. The cosecant's 1 over y. So you want to find 240 and find the y value. So you would be here. So the reciprocal of negative root 3 over 2 would be 2 over negative root 3. And then you can rationalize that denominator. And you'll get a negative answer. Okay, so you'll end up getting, and I just like to put the negative in the numerator. So you have 2 root 3 over negative 3. Best way to write the answer is like this, negative 2 root 3 over 3. Okay. Okay, number 8. Cosecant of negative 270 degrees. Again, that's 1 over y. Talk it out. The cosecant, negative 270 is clockwise. You would end up at this point when you go clockwise 270. The y value is 1. So again, it would just be 1 over 1. It'd be the reciprocal of 1, so that's equal to 1. Okay? And then the tangent of 90, or pi over 2. So when you do tangent of an angle on the unit circle, you look at y over x. Okay, just look at pi over 2, which is here. Y is 1, x is 0. So what you would have on that is you go 1 over 0, and you can't divide by 0, so that's undefined. Okay, so that's how you put that together then. Okay, just follow the definitions. You know the definitions, and can interpret this okay, you should be fine. Okay, next one's tangent of pi over 6. Pi over 6 is here. The tangent is y over x. So what you would have is 1/2 divided by square root of 3 over 2. I'm going to write it that way, just kind of remind you that when you divide fractions, you multiply by the reciprocal. Okay, so I'm going to turn that upside down. And then what I'll have is I'll have 2 over root 3. 2's cross out. You get 1 over root 3. And then if you rationalize the denominator, you get that. Okay. All right, the next one, it's kind of helpful on number 11 to do some of this one on the calculator. So what I'm going to do is we need to figure out where that angle is. So remember, the way that you can do this is pi is 180 degrees, so I'm going to go negative 17 times 180 degrees, which is pi, and then I'm going to divide that by 6. So what I have is I have really an angle of negative 510 degrees. Okay, well that's more than one lap around the circle, so if I add 360 to it, then I end up getting a coterminal angle negative 150. So the answer is going to be the same as the cotangent of negative 150 degrees. Okay, now if you count out negative 150, it's clockwise and you end up at that point. Okay, the cotangent is x over y. So what you would have is x would be negative root 3 over 2. The y value would be negative 1/2. So then you need to do the reciprocal of that. So what you would end up having is you would have negative root 3 over 2 times 2 over negative 1. 2's cross out. The negatives divide to a positive. So you end up with, let me double check that. I may have got a wrong answer on that. So square root of 3 over 1, so I get square root of 3. Okay, so I think I did x over y. I may have done that one backwards when I was working out the key, so that looks right. We're going to learn how to do something on the calculator on this. I can show you kind of how you could check your answer on this. Okay, I think I made a mistake on that. But I'm going to put my calculator in radian mode, which I'm in. And I'm going to do this basically. If I do a cotangent, you can do a tangent. And I'm just going to put in that negative 17 pi over 6. I hate it when it does that. So I'm going to do the tangent of negative 17 pi. And then divide by 6. Now that'll give the tangent, so I'm going to need to do the reciprocal of this answer. So one thing you can do is you can go 1 divided by this. And you can use the ANS key. That's a memory key, and you get that. Okay, so the answer is square root of 3. All right, sorry about that. And I make mistakes sometimes when I'm doing these. Nobody's perfect, and I'm not perfect or nowhere near it. Okay, so that's the answer you should have got on that. I think I did that backwards. And then the last one is the cotangent. Negative pi is halfway around the circle, so you'd be at this point, and then that would be the x value over the y value. Therefore, it's undefined. Okay? All right, so you want to make sure you're solid with that. You are going to do a lot of work in this section again with just doing the trig functions of angles on a unit circle. Everything else in here we learned is new, so that's just kind of a little bit of an overlap in the book. Okay, so I'm going to go down to the next page and kind of look at a little bit different kind of a problem that'll combine some things we learned in the previous section along with the unit circle. So in general, if you have any radius, now remember the unit circle is when the radius is 1, But you can have a circle with any radius. And the general definitions of the trig functions are the sine is y over r. In a unit circle, you're used to that being y over 1 or y. Cosecant's reciprocal r over y. Cosine's x over r. You're used to that being x over 1 or x in a unit circle. And then the tangent's y over x. So these are the definitions. These are the general definitions. If you remember r is equal to 1, then you derive those unit circle definitions like that. Okay? And then these are the relationships we know. The cosecant's 1 over sine. Secant's 1 over cosine. Cotangent's 1 over tangent because they are reciprocals. This statement right here is the Pythagorean theorem. X squared plus y squared is equal to the square of the hypotenuse, r squared, like that. So what I'm going to do is some kind of problems they're really exercises to help see if to get a student to learn their trig definitions a little better. All right. So what we're going to do on this one is you're given two things. You're given the cosine of an angle is 5/13, and you're in quadrant 4. And it turns out if you know one trig function and you know the quadrant you're in, you can easily find the rest of the trig values. Okay, so really what you do is you figure out what x, y, and r is. Okay, and once you do that, you can apply the definitions. So let's kind of look at this like this. The first thing is, okay, the definition of the cosine is x over r. So what that means is that that would be an x value, and that would be an r value like that. Okay, now you're in quadrant 4, so if you're in quadrant 4, you have a positive x and you have a negative y. So that means the answer to x is positive, the answer to y is negative, and r is always positive. All right, because it's a distance, it's a radius, so that's always going to be positive. So you do that. So what we would have then is x would be positive 5, y would be negative 13. All we got to do is find r, but you find that from the Pythagorean relationship. So just write down r squared equals x squared plus y squared, and then we can pretty easily figure out what r is, then we can finish the problem. So you'd have r squared equals 5 to the second plus the quantity, negative 13 to the second. That would be r squared equals 25 plus 169. Hold on, I'm doing this wrong. I'm not paying attention tonight. It's late. Okay, sorry about that. Let's try that again. We have r squared. I knew what the answer was going to come out to be, so I just kind of caught my stupid mistake there. Okay, so the radius is 13, so we'd have 13 squared. We know that x, I put stuff in the wrong place is what I did. So we know x is 5 squared. Well, we got to find y. Okay, I need to slow down and be careful of what I'm doing here. Okay, so we got plus y squared like that. Okay, so r is equal to 13. Okay, now y is going to be a negative value because we're in quadrant 4. All right, so what you'd have is 169 is equal to 25 plus y squared. And you can subtract 25 from both sides. So if you take 169 minus 25, you get 144 is equal to y squared. Okay, then you do square root of both sides. And when you do a square root of both sides, you really technically have a plus or minus, but because we're in quadrant 4, we know that we have a negative. Okay, so that would be negative 12 like that. All right, so see, if you're given a trig function, you're always going to know 2 of the 3 variables, x, y, and r. Pythagorean theorem gives you the other number, then the quadrant just narrows down the signs. So what we do now is real simple. The sign is y over r. Okay, so we would have negative 12 over 5 would be the answer to that. The cosecant is r over y. It's just the reciprocal, so that would be negative 5 over 12. Okay, the tangent is y over x, so you would do negative 12 over 5. Cotangent is x over y, the reciprocal, so that's going to be negative 5 over 12. And then finally, the secant is r over x, so that would be 13 over 5. Okay, like that. That's just the reciprocal of the cosine, so if the cosine's 5/13, the secant is that. Okay, so I kind of got off to a bad start there with making a couple of mistakes on this video. But that's okay. I'll be careful from here on out. So those are the answers. Again, when you see a problem like this, the whole focus should be, I need to find x, y, and r. And I need to know if x and y are positive or negative. If you do that, you use your definitions, then you get your answers pretty easily. Okay, so I'll move to the next page here, and I'll do one more like this, then I'll give you an opportunity to work a few of these out. I'll be careful on this one, okay? I'm going to zoom on this a little bit so I can see a little bit better. Okay, so you're given, first of all, you're given the tangent theta is equal to 2/3. So step one is to know the definition of the tangent is y over x. Okay, since you're in quadrant 3, when you're in quadrant 3, x and y are both negative. So you got to be careful on this problem, okay? X is going to be not 3, it's going to be negative 3. Y is going to be negative 2 because you're in quadrant 3. And remember, you're going left and down, so both x and y are negative. So we got x and y, okay? Now we find r. How do you find r? Okay, you do the Pythagorean theorem. Okay, just that. Okay, we know x and y. We plug it in, we'll find r. So we have r squared equals negative 3 squared plus negative 2 squared. Okay, so well, it should be enough to figure out what r is. So r squared is 9 plus 4. R squared then is equal to 13. Then what you do, of course, is do the square root of both sides. And when you do that, technically you get r equals plus minus square root of 13. But remember I said that r is always what kind of number? Yeah, it's positive. It's a radius. A radius is a positive number. Okay, so you got those numbers in like that. Okay, so now you're in business. So now when you get the remaining 5 trig functions, you just have to know your definitions. So the sign is y over r. So y is negative 2. R is root 13, and you want to, of course, rationalize that denominator, which I'm okay if you do that in your head. So you would end up with the answer, negative 2 root 13 all over 13. So that's the value of the sign. Okay, if we go on to the cosecant, cosecant's r over y. So r is square root of 13, y is negative 2. Now what you want to do, I'd prefer that you put it like this. I'd prefer that you write it as negative root 13 over 2, or just put the negative directly in front of the fraction bar. Those are the two preferred ways to write a negative fraction, is like that. All right, so that'll take care of that. I kind of like either of these two answers best. Okay, now the secant, its definition, r over x. So we have r as the square root of 13. We have x is negative 3. So again, the same thing. I prefer that you write that as negative root 13 over 3, or put it directly in the fraction bar, in front of the fraction bar. And that's already rationalized, so you don't need to worry about that. Okay, so the secant's r over x. Okay. Okay, the next one is the cosine. The cosine is x over r. X is negative 3. R is root 13. So again, you're going to rationalize the denominator, which again, you can do in your head. So I'm going to multiply like that. Okay, that's going to give negative 3 root 13 over 13 as an appropriate answer of the problem. It's in a rationalized form. Okay, so see, the whole key on this is to get x, y, and r and get the signs right. The most common mistake students make is they get the signs wrong. But the quadrant's going to tell you that. Okay, and then the last one, what's a cotangent? A cotangent is x over y. So x is negative 3, y is negative 2. If you divide a negative by a positive, you get a negative divided by a negative is a positive, so you get that. Okay, and notice this, I want you to notice this. I gave you the tangents 2/3, therefore the cotangent's the reciprocal, so it's 3/2. You could have just done that automatically like that if you want to. Okay, so that's the idea. All right, so when you focus on these problems, you got to know the definitions of the trig functions to know what you've been given. Figure out the two things you've been given. find the third thing with Pythagorean theorem, then it's straightforward, a matter of looking at your definitions. You want to try to get your definitions down as fast as you can. So what we're going to do is I'm going to let you pause here and do the next two problems. Now I'm going to write this down just so that you don't have to scroll back between these. So just kind of the sine is y over r. The cosecant is the reciprocal. Okay, the cosine is x over r. The secant is r over x. Okay, the tangent of theta is y over x. And then the cotangent of theta is x over y. And then don't forget you have the Pythagorean theorem, r squared equals x squared plus y squared. Okay, you're used to that being c squared equals a squared plus b squared. It means the same thing. Okay, you have a right triangle. So go ahead and pause, and I'll work them out, and then when you're ready to check, just check, and if you get them right and understand, you can move on, okay? Okay, so check over your work, see if you got the right answers. I got all those highlighted. If you got them right, then you can move on and understand them. Otherwise, I'll kind of just go through this a little bit and show you my thought process if you need some help. Okay, so the secant is r over x. Okay, that's your definition of the secant. So that means r is 5, x is 2. You're in quadrant 1, and in quadrant 1, everything's positive. So you have a positive x, positive y, positive r. So that's your first thing. Then you do the Pythagorean theorem. And when you do the Pythagorean theorem, you can look through the details. I got plus or minus root 21, but again, it's positive, so I got that. Okay, so once you get x, y, and r, all I did is go the definitions. The sine's y over r, root 21 over 5 is the answer. The cosecant is the reciprocal, so I just turned that upside down to get 5 over root 21. I didn't really show the step on that, but I'm rationalizing the denominator then to get that. Okay, and then the tangent's y over x, so root 21 over 2. Cotangent is the reciprocal, so it's 2 over root 21. And then rationalize. Then finally, the cosine's x over r, so it would be 2 over 5. Okay? And notice in this problem, see, I gave you the secant. The cosine's automatic. I mean, you don't have to work anything out on that. You just do the reciprocal. Okay? Okay, the next one is another example of what we call a Pythagorean triple. You have 3 whole numbers that satisfy the Pythagorean theorem. So 7, 24, 25 could be the sides of a right triangle, where 25 is the hypotenuse. So I gave you the sines negative 7 over 25. That means y is 7, r is 25. Now, how do I know which one's negative? Well, remember, r is always positive. So if r is always positive, that's 25, and that forces that 7 to be negative. So it goes like that. If you're in quadrant 4, again, you have your over and down, so x is positive and y is negative. So you had to figure out that since you're in quadrant 4, x is positive, y is negative. Okay, the Pythagorean theorem, you can look through the details of what I've done there. Students generally do very well with that. So I got 24, and once you have these 3 numbers, then just follow the definitions. Cosecant's r over y, so that's 25 over 7. Just put the negative in the numerator. Cosine's x over r, so that's 24 over 25. Tangent's y over x, so that's negative 7 over 24. Cotangent's reciprocal of tangent, so flip it to get negative 24 over 7. And then the secant's the reciprocal of the cosine, so 24 over 25 turns into 25 over 24. Okay, so again, these problems where you're working about, just your focus is, I need to figure out what x, y, and r is, and I need to get the signs right due to the quadrant, and it's a matter of doing the definitions, and when you have to rationalize the denominator, be sure you do that. Okay, so that's kind of the idea there. Okay, so that is the end, actually, of part 1, and then I'll have a separate video for the second part here.